Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us into our discussion today. I'm going to look at an interesting concept under differentiation. This is going to be a topic in differential calculus that is going to be dealing with the concept of stationary points. Now, in this particular case, we're going to look at various range of graphs which are going to be assisting us try to, of course, identify this aspect of stationary points. And they're going to be assisting us in trying to perform what we refer to as the concept of graph sketching. And in this particular case, the stationary points basically are going to be achieved from considering this specific concept of differentiation. And in our last discussion on the concept of differentiation of various functions, we basically defined the concept of a differentiation as finding derivatives of various functions. And of course, we're going to see that in this specific case, there's of course a range of graphs which we had considered. And I'm going to consider a specific general case of a graph which can be defined in terms of y as a function of x given as such. And we said that for us to find generally a derivative at a specific point, we said that we're going to find this specific, of course, a gradient form, which is going to be a tangential line to this particular point, which we can give in terms of a p. And therefore, if you consider the, of course, a plane of xy coordinate system for xy plane, we are going to see that we can find the derivative of this specific or the derivative or this specific point by considering the change along the x-axis and the change along the y-axis. And this is going to be forming a ratio of dy for the change in x and dx for the change in those two specific, of course, edges for the right triangle, which is going to be resulting from this specific consideration. Now, in this particular case, we are given a notation which can assist us try to find this specific derivative, and this was given in terms of f prime over x is equivalent to dy all over dx given as such. Now, there are some instances which we are going to come across various derivatives which we are going to find from this specific process of differentiation, whereby we're going to find the value for this dy all over dx equivalent to 0. Now, in this specific point, we are going to see that there are various names which we can use to, of course, indicate these specific values in different, of course, equations. And these are going to be forming what we refer to as our stationary points. Now, in some literature which we are going to come across, of course, they are going to be given in different, of course, forms, which can be either given in terms of critical points, which are going to be given in terms of stationary points. Now, we're going to consider a case whereby we're going to have particularly three basic graphs, which we can use to consider a various range of instances whereby we're going to have this specific aspect of course, the derivative, which is given in terms of dy over dx equivalent to 0. And these are the curves which we can consider for this specific curve. And then we're going to consider this specific curve given as such. And these are going to be the two curves which we are going to describe according to that specific, of course, range of course, dy over dx. So if you consider a section of this specific graph, which is going to be given using this tangential component, which is going to be coming from the left towards the right, going downwards. So let's say this is going to be a point A to B. So for us to describe this specific, of course, a change of graph between A and B, we're going to consider the change in x over change in y from the left side to the right along the x-axis. And this is going to be showing us that if we try to find a derivative at a particular point, this is going to be showing us that we're going to have this change in the y all over change in the x given as such. So as we proceed along the x-axis, we're going to see that there's going to be a decrease in the y-axis, and therefore we're going to denote this change between A and B as a negative value. So in this particular case, we'll be indicating this specific change using that short form of either positive or negative value. And in this case, for such a kind of a graph, we're going to have a negative change given as such. Now, suppose we have a line that is going to be showing us the gradient at this specific point which is going to be the lowest section of this particular curve, we're going to see that this particular line is basically going to be parallel to the x-axis. Now, therefore, it's going to be denoted as a value of y, which is going to be giving us the gradient that is equivalent to 0. So basically, we're going to regard to this one as a stationary point. And later on, we're going to see that there are some specific terms that we're going to use relative to other curves, which are going to be assisting us of another description for this kind of a change. So if we have a gradient that is showing basically an increase from left to right, which is going to be opposite trend from the first one, we're going to have what we refer to as a positive change in y over x given as such. So such a kind of a description can assist us in trying to contrast the first curve, which is going to be the y, which is given as a function of fx given as such. Now, if we find another graph which is given in terms of y is equals the g of x given as such, we can as well describe different points which are going to be considered for the change from left to right towards this specific case we had said is a positive trend. And then we said that this specific point for a line that is parallel to the x-axis, this is going to be giving us a stationary point given as such. And of course, lastly, we're going to see that if we consider a particular point at this specific section, it's going to be a negative case. So in two cases, we're going to see that we're considering the neighborhood of this, or the neighboring, of course, trend for the curve of this specific stationary points in this particular case. And this is going to be giving us a trend of particular points which are going to be having this specific case for the negative point, the negative trend, 0, and then we're going to have a positive trend given as such. And we have said this is going to be given as a stationary point, just as the second case. But for this kind of a graph that is going to be having a negative 0 and a negative, this is going to be given a particular term that we refer to as a minimum. And if we have another graph which is going to be, for the second case, having a positive, and then we're going to have a 0, and of course, a negative. This is going to be giving us what we refer to as a maximum. So this specific wording for the maximum and minimum is going to be relative to the y-axis. And as we're going to see, this is going to be assisting us try to depict the specific trend for this specific curve, which is curving down and going up given as such. And for the second one, it's going to be curving up and coming down like that, and therefore it's going to be giving us a minimum and a maximum respectively. Now, if you consider a case of a particular graph which is going to be, perhaps if you consider a B, and a C1. So for a C, which is basically going to be given in terms of perhaps a curve having this specific trend. So we can have another one which is going to be having this specific trend. So if you try to consider this specific two curves, we're going to have a situation whereby we're going to have a change of a negative given as such, which is basically equivalent to this one. And at this specific point, we're going to have a stationary, which is going to be given as 0, and another negative given as such. But for this one, we're going to have a positive trend, which is going to be a positive increase along the x-axis. And then we're going to have a stationary point at this specific level and another positive given as such. So there are also two specific terms which we are going to be using in trying to name these particular curves. And if we give this one as C and D, now the combination of a C and D are going to be forming what we refer to as points of inflection. And these points of inflection are going to be either described for the rising curve and the falling curve with respect to this specific point of origin along the x-axis. So in this particular case, we're going to have a falling curve. And for a falling curve, this is going to be the curve described for C, which I've given as such. And for a rising curve, in this case, we can describe just this specific notation which we had given above, whereby we're going to have a negative and then 0, negative, which depicts a falling curve. And then we're going to have a rising curve given in terms of this specific representation for a positive trend, and then 0, and then a positive given as such. So the two are going to constitute what we refer to as points of inflections at these specific points of minimum, or rather at this specific point which we are regarded to as a critical point. And of course, we're going to see that we can have a general description in terms of this particular aspect of a change in x and y, which are going to be assisting us differentiate between the 2 points. But these are going to be regarded as points of inflection for the first one, which is a point of inflection on the falling curve given as such. And this is going to be a point of inflection for the rising curve given as such. So at the stationary point, as I just of course stated from my opening statement, we're going to have the change in y over change in x given in terms of 0. And of course, I'm going to give just a summary of that specific representation for us to do a follow-up of what we have basically discussed. So I'm going to do away with this and have these specific points described as such. So we have basically stated that we are going to have this specific description for the various points which we have identified for critical or stationary points. And in this case, I've said that if we have dy over dx given as 0, so these are going to be depicting a stationary point which I've already regarded in terms of critical points. So sometimes they can be referred to as critical points, which are going to be giving us various range of graphs for the minimum and positive, as I had said. So suppose we have this specific derivative, the second derivative with respect, of course, to x given in terms of this specific representation given as greater than 0. So this is going to be the first differential of this specific curve, and the second one. Now, if the second differential of this specific function or the curve is going to be greater than 0, and of course, this is going to be regarded as the minimum. And if we have the second differential of this specific, of course, function given in terms of dx, dy, dy, dx given as such, of course, smaller than 0. And this is going to be taking the form of what we refer to as the maximum. And these are some of the ways in which we are going to differentiate between these specific critical points which I've just given for maximum and the minimum. Now, for the stationary points which we have, of course, given in terms of points of inflection, either this specific set for the second derivative which has been given in terms of dy all over dx is going to be equivalent to 0, and these are going to be differentiated through the sign or are going to be given, of course, a point of inflection which are going to be either changing the signs through these specific points which are given for the falling curve or the rising curve given as such, and these are going to be forming the points of inflections which are going to be changing this specific trend for the curve, just as I've mentioned. Now, in our subsequent videos, we're going to look at there are different ways of trying to, of course, show these specific functions in terms of stationary points, and of course, summarily in terms of these critical points which I've mentioned for the maximum, minimum, and points of inflection. And that's going to be assisting us try to, of course, have this specific concept being more comprehensive in such a way that, of course, we can be able to identify these critical points in case we come across them in our various range of our discussions. So that is it for now, guys. By God bless you. Catch us in our next video.